Namaste. In previous classes, we discussed regarding how to compute static indeterminacy of the given structures. Let us we move on to kinematic indeterminacy or degree of freedom. See, what is meant by kinematic indeterminacy or degree of freedom? This is nothing but, see, in previous in static indeterminacy, we just talked about reactions, external reactions, as well as internal member forces and all. Now in kinematic indeterminacy, I'm talking only a joint displacements. Joint displacements. What is meant by kinematic indeterminacy? It is the summation of possible joint displacements in a structure. So I'm talking about displacement, then I'm talking about kinematic indeterminacy. If I am talking about reactions and forces in internal forces in members and joint equilibrium conditions, it's all associated with static indeterminacy of the structure. Now let us see what are the possible displacements at different types of supports. Let us see, we are having a free end. If you are having free end, see, basically in displacements at each joint can displace in three direction. That is, along x direction it can displace, along y direction it can displace, or it can rotate, or it can moment will create. That is rotation. Clear? So totally we are having two translation. Translation is nothing but displacement along axis. X and y are translations, and rotation, that is one rotation, two translation and one rotation. Totally we are having three displacements at each joint. So the reactions or prevent the displacements. So with respect to reaction, we have to see, observe each and every joint. Then we have to count the possible displacements. Possible displacements. If you are having free end, the degree of freedom is 3. So the free end can move in x direction, it can move in y direction, or it can rotate, That's why, because why? Because it is not having any kind of supports. Hence, the free end can move in x direction, can move in y direction, and also rotate. But if you come to simple or roller support, what happens? Generally at simple support, we are having vertical reaction. This vertical reaction will prevent the vertical displacement. This vertical reaction will prevent the vertical displacement, but it allow horizontal displacement as well as rotation. It allow horizontal displacement as well as rotation. Hence, if simple or roller support are there, there are 2 degrees of freedom. Okay. Similarly, if you are having hinge support, see, generally how many reactions are developed in hinge support? There are two reactions, one in vertical direction and one in horizontal direction. But hinge will allow rotation. Hinge can allow rotation. Why? Because the reaction will develop in x direction and y direction, but the possible displacement at each joint are two translation as well as one rotation. Hinge joint can prevent two translation, but it will allow rotation. But if you come to fixed end, what happens? Fixed end is a rigid. Why? Because fixed end we are having three reactions: vertical, horizontal, as well as moment. Hence, it prevent all three kind of displacement. Hence, at fixed end, the degree of freedom is 0. Clear? So, depending on these degree of freedom, we have to count at each joint. The sum of displacement will give the kinematic indeterminacy of the structure. Okay. Let us we move on to first problem. In first problem, see, observe each joint. The possible displacements are vertical displacement, horizontal displacement, and rotation. At each joint, the possible displacements are three possible displacements. Clear? Now I'm coming to A joint. A having fixed support. Fixed support will develop horizontal reaction, moment, as well as vertical reaction. Because of this vertical reaction, there is no vertical displacement. That's why here 0. Because of this horizontal reaction, there is no horizontal moment, 0. Because of this moment, here the moment is also 0. This displacement is resisted by this moment. This displacement is resisted by this reaction, and also vertical displacement is resisted by vertical reaction. Let us move on to support B. Now because of this vertical support, it is 0. Now here it can moment, theta is possible, it can rotate, so theta A, but it will not move along axis. Why? Because of this fixity. Because of this fixity, it will not move. If you are not having fixity here, if you are having simple support, then it can move. Clear? But here we are having fixity. Because of this fixity, the horizontal reaction here also it will resist in a member. That's why at joint B, this is also 0. Similarly, at joint C, because of this vertical reaction, here the displacement is 0. Because of this fixity, here at C also the horizontal displacement is 0, but it can rotate. Theta C is possible. Now, what is the degree of freedom? I am talking about each joint. What is kinematic indeterminacy? It is the total number of independent displacement at member. Clear? Now, this structure is continuous beam. The given structure is continuous beam. Hence, it cannot undergo sway. See, beam cannot undergo sway. But the unknown displacement components are theta B and theta C. Theta B and theta C. Totally, we are having degree of kinematic indeterminacy 2. Theta B 1 and theta C. So, the kinematic indeterminacy for the given problem is 2. Let us move on to second problem. In second problem, the normal frame is given. Clear? Observe each joint. See, this is overhang. This is, don't consider this as a free end. This is, here I am having load. That's why it will create a moment here. This is an overhang. Clear? This is not free end. It's an overhang. Now let us see, consider each joint A, B, C. A are having fixity. Fixity matlab, there is no horizontal displacement. There is no vertical displacement. In rotation also, there is no theta moment. Because of this moment, it will resist. So here at joint A 0. At joint C also fixity fixed. Therefore, what happens? All three displacements are 0. But if you come to B, because of A fixed VA, it will not allow to move in vertical direction 0. Because of C fixity HC, here B delta, that is B will not move 0, horizontal will not move 0 because of C fixity. In case if I provide here simple support, it will sway. It is subjected to sway. It will move. Clear? The column will move. Now this column will not move because here I am having fixed condition. Once again, here also this will not move because at A it is fixed. The only possible is at joint B, that is rotation. Therefore, the degree of kinematic indeterminacy of the given structure is theta B, that is only 1. So, for kinematic indeterminacy, please observe carefully at each joint displacement. Joint displacement is possible only in case of there is no reaction at particular joint. Okay. Next, we move on to, this is rectilinear frame. In the rectilinear frame, first you observe joint A. This is fixed. Because of this fixity, there is no horizontal displacement, there is no vertical displacement, as well as there is no rotation, there is no moment. Clear? That's why 0. Once again, here you observe joint D. Here also the same case as previous A. That's why here also all displacement components along X, along Y, along rotation is 0. Clear? But if you come to joint B and joint C, because of this vertical reaction, vertical component is 0. Here also because of this vertical reaction, here also the vertical component displacement at C is 0. But what happens? Come to horizontal component. What happens? Come to horizontal component. Here we are not having any supports. At joint C I am not having any support. At joint B I am not having any support. So it can move. It will move. It will move. It will move. B move to B dash. C move to C dash at the same amount. At the same amount. This is a very, very important thing. It is not delta B or delta C. It is delta B and delta C. Both are equal. Delta B equal delta C, which is equal delta. Which is equal delta. Same amount. B dash equal C dash. Hence, this is horizontal sway. It will sway. It is wave frame. This is sway frame. All rectilinear frames are sway frames. It is sway frames. because here I am not providing any support, it will sway at the same amount. Clear? And also the rotation is possible. Theta B is possible here. There is no resisting. Here also theta C is possible. There is no resistance with moment. Clear? Now, what is the sum of degree of freedom at joint A 0, at joint B theta B and delta, at joint C theta C and delta. Don't take as delta B and delta C. It is in equal amount. That's why you take this is delta. Now the kinematic indeterminacy of given rectilinear frame is 3. That is theta B, theta C and delta. And the given frame is sway frame. Clear? This is regarding the in case of frames, beams. Okay, now let us move on to some important problems, like if I impose some extra conditions like internal hinges to the beam, to the frame, and also in trusses, what the if truss is given, how to compute degree of freedom and all in the next problem. So determine the degree of freedom for the structure shown in figure. Here I have imposed one extra condition in the form of internal hinge. Here also I imposed internal hinge. How to compute degree of freedom for these kinds of structure. So these kinds of structure, if you give in your examination, this can be computed using empirical relation in easier manner. Okay, there are several ways, but use empirical relation. That's the very easiest way. Okay, what are those empirical relations? The degree of freedom for pin jointed frame truss, pin jointed, that is truss, is given by 2j minus r, tk equal 2j minus r, two joint equilibrium conditions and number of external support reaction. Clear? Similarly, degree of freedom for beams and rigid frames, for both the cases, beams as well as rigid frames, use 3j minus r plus imposed conditions, Clear? Let us move on to first problem. In the case of beams, first compute external support reaction. At A we are having HA and VA, at B we are having VB, at C we are having VC. Clear? The total number of external support reactions are 4. How many joints? 1, 2, 3, 4. Here also, because of imposing hinge, it will create a joint here. It will become 4. Clear? Now substitute all these values. We are having only one hinge. Substitute all these values in this empirical relation. dk equal 3j minus r plus number of internal hinges. It will become 9. So total degree of freedom for the given structure is 9. Let us move on to second problem. So in this rectilinear frame, I am imposing hinge at joint B. Clear? Now the joints will become only 4, because if I impose some other point, it will create a joint. At joint I am imposing, hence the number of joints are 4, and number of external support reaction here fixed 3 and here hinge 2. 3 plus 2 5. Total number of external reactions 5 and number of internal hinge is 1. Just substitute all these values in this empirical equation. 3j minus r plus number of internal hinges, we are getting 8. Therefore, the degree of freedom for the given structure rectilinear frame is 8. Next, we move on to trusses. In trusses, the degree of freedom is 2j minus r. So count number of joints. In the given truss, we are having 1, 2, 3, 4, 5, 6. 6 number of joints, and compute external support reactions. How many external support reactions we are having? At joint A, there are 2 external support reactions, VA and HA. At joint D, so only 1 vertical reaction, VD. Totally 2 plus 1, 3. 3 external support reactions, 6 number of joints. Substitute in this relation 2j minus r, we are getting dk equal 9. Therefore, the degree of freedom for the given truss is 9. Clear? So in this particular tutorial, we discussed regarding how to compute joint displacement or degree of freedom at each joint, and also for element it is the sum, then it is called degree of kinematic indeterminacy. And also we solved some special structures for special condition, imposed conditions like internal hinges, and also for truss using some empirical relation. I hope you are getting how to solve these questions in the easiest way. Thank you for watching these particular topics. If you are having any doubts, please contact to my mail address or put a mail in my inbox. Okay, thank you.